Welcome back to DellyMaths Concepts. Today we are looking at a geometry question where that has to do with cross-section. A rectangle pyramid is shown where the dimensions of the base are 12 centimeters by 21 centimeters, and the pyramid's height is 33 centimeters. So the question is here. It says, what are the dimensions of the cross-section parallel to the base that is located 11 centimeters above the base? In other words, we want to know what the dimension of this rectangle here, right? That's what we really want to do. We want to know what that is. All right, let's see how best we could put it together. Now, one of the things that we are going to use here is the fact that the original pyramid, which is the larger one all the way down here, it's going to be similar to this other one when cut here. They are similar, and we're going to ride on that idea of similarity to solve the problem. Now, let us label what we got first. So we're looking at a 21 centimeters by 12, and that's the base of that pyramid there. And then we were told that it was cut 11 centimeters from the base. So right here, this is the slicing that took place. It's an horizontal slicing, and it's 11 centimeters above. Another information that we got was that the height of the pyramid here was 33. So from this highest pinnacle touching the bottom here, that's 33. So I'm going to put it at the side right here. 33 centimeters. Now, we're going to take this information, and I'm thinking here that I'm going to be writing on the height of the smaller pyramid right about now. Now, if I am to imagine this distance at the top, and if I was to move from here going up here, this distance is of great importance to what I'm about to do, right? If I could find that distance, and that distance can be found by taking 33, and I'm going to subtract 11 from this, and I'm getting 22. So this distance from the top here to the base here, this height right here, is actually 22, right? So that is 22 centimeters right here. Now, having that, there is two things that I have here. I have already established that the two pyramids are similar, okay? Because one was just a slice of the other one, so they are similar. Their heights are in proportion. So what I'm going to do is to find the relationship, that ratio between the corresponding heights that we have here. So I'm going to say, okay, let us say we put 22, which is the height of the smaller pyramid. We want to put that as a ratio of the height of the bigger one. So in this case, if we should cancel this down by using 11, if I should divide this by 11 and divide this by 11, I am getting 2/3. What this is suggesting is that this smaller pyramid here, right, every corresponding side to the bigger one is 2/3 of it. So it's not just their heights that are in proportion. Corresponding sides, what do I mean? If I find 2/3 of 21, it's going to give me this side that correspond with the 21. Also, if I find 2/3 of 12, it's going to give me this side here that correspond with it. And that would have given me the dimensions that I need. So first and foremost, let's put together having the length, which is actually equal to 21 cm. Let us find 2/3 of that length. So 2/3 of 21, if we work this out, 3 to itself 1, 3 into 21, 7. 2 times 7, that's going to give me 14 centimeter. It is telling me that this side of that base right there is 14 centimeters right there. So for the width the original width would have equal to 12 centimeter, and I'm referring to the base, all right? Now we're gonna take 2/3 of the 12, and it's gonna help me to find the corresponding width when we sliced it. So 3 into 12, 1, 3 into 12, 4, 2 times 4, and that's definitely 8 centimeters. So it means then that that width there is 8 centimeters long. And that would have given me the dimension of the cross section when it is cut at 11 meters above the ground. So we utilize similar ideas, similar objects, right? And maximize that thing. Thank you for watching DellyMaths Concepts, and see you next time. Bye.